a second, and I'll take your questions. All these cross-country guys not. But, who had the question? Got the question?
I actually got no money. I gave no money.
Got your what?
Grabbed the wrong one.
Wrong binder. Like your notebook? Sure. Okay, let's take a look at the Bellward question, and then we'll pray, then we'll get on to today's lesson. Yesterday at the end of class, we were doing polyatomic ion. We did phosphate. It should be the last thing in your notes. So if you follow the steps of that one or the previous ones, we did 3 of these in class yesterday on Lewis structures. We're going to follow the exact same steps we put in our notes yesterday. The first step says decide which of these atoms, nitrogen or hydrogen, is going to be the central atom. In this case, it's kind of obvious. Since hydrogen is always a terminal atom, nitrogen is going to be in the middle. The second step says add up all of your valence electrons. So somewhere on your sheet of paper, I usually do it on the right-hand side here, but you don't have to. I'm going to add up how many valence electrons from each atom, add them all up, take into account any electrons from the positive or negative charge, make an adjustment, and get my total number of electrons available. So nitrogen has how many valence electrons, Sarah?
6.
Close. Good, okay. 5 from the nitrogen, and each hydrogen has how many, Charcy? Hydrogen. Yeah, its atomic number is 1. It only has 1 electron. It can only give 1 electron. And since I have 4 of them in NH4, there's 4 hydrogens times 1 electron apiece equals 4 electrons. So 5 plus 4. I need to do something with this. So just like the phosphate one we did at the end of class yesterday, where we saw phosphate was negatively charged, and that meant we've got extra electrons. This one's positively charged, so that means it's missing an electron. Okay, so something that's positively charged means it's already given away 1 of its electrons if it's positive 1, 2 of its electrons if it's positive 2, or 3 of its electrons if it's positive 3. So in this case, we've given away electron. We actually need to put a negative 1 over here. We actually need to subtract 1 to take into account this plus 1 up here. You say, why is it opposite? Again, a positive ion means it's lost an electron. So this is a total of electrons over here. 5 plus 4 minus 1, 8. Okay, so we've got 8 electrons to play with. We're going to divide this number by 2. I know the math is really tough. Don't dare take out a calculator during this kind of thing, okay? 8 divided by 2, everybody? 4. Okay, good. So we have 4 pairs of electrons to find a home for. Some of those are going to be bonds. And the next step in our steps yesterday said start by putting a single bond between each of the terminal atoms and the central atom. So how many have I used? I've used 4 of them, and I have 4 of them available. The next step says if there's any extra electrons, there aren't, so I don't need to follow that step. The next thing says check and make sure your central atom has its octet. So we're going to kind of look at nitrogen here, say does nitrogen feel like he has 8 electrons? 2, 4, 6, 8. Sure. And remember, hydrogen can only have 2, so each of these hydrogens can only have a single bond, which is what we're showing on there right now. Single bond, single bond, single bond, single bond. Now, in order to finish this Lewis structure, because we're basically finished, we need to put it in a bracket and show that it still has a positive 1 charge. Okay? So anytime you have a polyatomic ion and you're drawing the Lewis structure for it, your final answer has to have the big square bracket around it showing the negative or positive charge out here. Okay? And this is the Bellward question for today. You'll have some homework problems to do on this over the weekend. We're going to do some more, another type of these today in a few minutes after we take the quiz. And good, Lewis structures. Good. Right now I want you to turn in your News articles, so take out your 2-paragraph news articles and pass those to the back, please. We'll take a few prayer requests. We're going to pray for the cross-country team and the football team. Anybody else have other prayer requests besides those? Who? Halftime show. Yeah, cool. Hopefully the ground stays moderately dry. So pray that the rain stays away today so we can have a nice night out at the football game and the halftime show is not in mud and the football players aren't in mud. Anybody else for request today? Miss Tanya Flynn, good. And don't forget Caitlin, of course. Jesus, we love you. We thank you, Lord, for this day. Ask you, Lord, please to bless the day, the football game, the cross-country meet, Lord. We ask you for no injuries. We ask you for dry ground. We ask you, Lord, for success and victory. Ask you the halftime show tonight for all those participating, the Ram Corps, flags, all the different groups, the dance team. Ask you, Lord, to give that success. Help us, Lord, to be a good testimony in front of our visitors of the opposing team as well as those who come to watch this playoff game. Ask you please to be with the weekend coming up. And thank you, Lord, for all that's going on in our lives. Give us a good day today. In Jesus' name, amen. Okay. Here's what we're doing. We're going to clear our desks and take a quiz on the stuff we've covered so far this week. While you're taking the quiz, I will pass out bonus tickets from last Friday's test as well as Wednesday's quiz. Okay, so if you got those coming, I'll be dropping those on your desk. Let's go ahead and start with the quiz next, though. Fire up Google Classroom, find quiz 8B. 8B. I have one up here for anybody needs one. Yes. Yesterday. But it's up to you. Guys, settle down, please, and let's get logged in. Quiz 8B, please. Some of these questions will look very familiar from earlier in the week, but not all of them, okay? So, if anybody's interested, Monday night at 7 p.m., the Mobile Pops has a concert. It's free. It's at the Battleship inside the hangar, which is kind of a cool setting, surrounded by the jets and stuff like that. And, who put that there? And Mr. Martin is in the percussion section now, and myself as well. Not in the percussion section, but so you're all invited if you want to come. That was fun. If anybody needs scratch paper, let me know. I don't know if you do, but if you feel like you do, you're welcome to it. You can have your periodic tables out if you want. Basically, until further notice, unless I prohibit it, you can use the periodic tables on any quiz or test for the rest of the year, okay? Just have them handy if you ever need them, so you don't need to dig them out in the middle of the quiz in the future. I had a stack out on one of the chairs. I missed a stack of paper. Rebecca. No?
I have a stack of paper. It was almost there. I took it.
You confiscated.
Okay.
That's my scratch paper. I don't know if anybody's.
Not all of it.
No, not all of it was mine. Mine was kind of like, yeah, this part. You can tell. Anybody else need paper? Over there. explain it next week. Remind me about it. quiz, go ahead and log out and put the Chromebook underneath your desk, please. Got your notebooks. Give you 2 or 3 more minutes if you need to finish up the quiz. Anybody else have scratch paper? No talking, please. A couple people finish that quiz, okay? Okay, take out your notebooks and write this down in your notebook. We're going to finish up. Yesterday we were covering how to draw these Lewis structures. I got one more type to show you. Okay, yesterday we started with a simple one, I think it was pH3. And then we did one with double bonds, it was carbon dioxide. And then we did what, polyatomic ion one, phosphate, PO4. We saw how to handle that -3 thing. For bell work today, we did ammonium, which had a positive ion, okay? And we got one more thing to cover as far as drawing these structures. Then most of your homework this weekend will be this worksheet where you're going to draw these structures. You can try and draw them on here. I'm not sure there's enough room on this. We'll save the backside for next week for some practice and review. But this weekend's homework will be to draw these 8 structures. Do your best. Follow the rules that we put in our notes yesterday, those 7 steps. Follow the examples we've covered in class. okay, and you should be able to get these. And then there's one question at the bottom. You'll need to draw the structures, obviously, for the other two sulfur and oxygen compounds in order to compare them here. The other thing you're going to do for homework this weekend, please, is read section 8.4. We're going to do that on Monday. Tuesday next week, we'll have a lab. We need to get 8.4 covered in order to do the lab on Tuesday. So read that, please. It will definitely help you be ahead of the game on Monday's lesson as well as Tuesday's lab. We're still going to have one more section to cover after that, so it looks like I'm going to have to bump our next test net back to next Friday, which means we'll be working on section 5 next Wednesday and Thursday and doing some review. Okay, so that's the plan anyways. I haven't even written out the lesson plans yet, but that's my plan. Okay, nitrate. Here's our nitrate atom. Step number 1 yesterday said determine which of these atoms, nitrogen or oxygen, is going to be in the middle. Now, if we don't know, it's kind of obvious in most cases. If there's only one of them and a bunch of another one, then the one that's usually singular goes in the middle. But if we don't, suppose I had carbon monoxide. Well, neither one's going to be in the middle. That's silly. Okay, never mind. But if there is a question about it, it's the one that has the furthest left on the periodic table, or the one that has the lowest electronegativity, is the one that's going to be the central atom. Most of the time you don't have to ask that question, but there will be a few. Like on the first one here, C, carbon, hydrogen, and fluorine. Which one are you going to put in the middle, carbon or fluorine or hydrogen? You'll figure it out by looking at the periodic table and choosing the one that's the farthest to the left. In this case, it's nitrogen. Step number 2 on our list said add up all of the valence electrons. So in this case, I'm going to make a little list. I've got 1 nitrogen and 3 oxygens. And each nitrogen has how many valence electrons, Michaela? Let Michaela figure it out. She knows how to do it.
Here, show up.
Oxygen has how many valence electrons, Ben? Good. Group 16 has 6, group 15 has 5, group 14 has 4, group 13 has 3, group 2 has 2, and group 1 has 1. So 1 times 5 and 3 times 6, we got this. Now, remember, if you add that up, you're going to get an odd number, and there should be a clue that you need to do something. So we go back and look up here and say, oh, I got a -1. Does that mean I add 1 electron in or subtract 1 electron from this over here? True? Add 1. Okay. A negative charge means I have an extra electron. So that's going to be the +1 we add over here, 24. Okay, step number 3 says, divide this huge number by 2. Cole, 24 divided by 2?
12.
That is tough math. You don't need a calculator for that.
Sir? Hold on.
Don't let me see you take your calculator out for that, okay? Okay? Not for these, okay? So now, step number 4 said, we're going to start with a single bond, and we're going to attach 3 oxygens in this case. So oxygen, oxygen, oxygen. That uses up 3 of these 12 bonds, or 12 pairs of electrons. A pair of electrons can either be a single bond or a pair of unbonded electrons that floats around in their orbitals. I've used 3 out of 12. We got to find a home for 9 more pairs of electrons here. So the next step on your list, and I'm going to remind you where they are, okay? So we covered step 1, central atom. Step 2, add up the electrons. Step 3, divide by 2. Step 4, place a single bond to connect all of these together. Step number 5, complete the octets of the atoms bonded. So now I'm going to go back here, and I'm going to start putting all my little dots. 1, 2, 3, 4, 5, 6. That's 3 pairs. 1, 2, 3, 4, 5, 6. That's 3 pairs. 1, 2, 3, 4, 5, 6. That's 3 more pairs. So I got 3, 6, 9. And the 3 that are connected to the nitrogen. I got 12 pairs of electrons here. I got 12 pairs of electrons to use. It looks like I'm done. Don't stop here. Okay? We're going to go back and we're going to double check our rules. If there's any leftover electrons, put them on the central atom. There aren't. Determine whether the central atom has its octet satisfied. So that's the question. Is nitrogen happy?
Yes.
No, okay? He only has 2, 4, 6 electrons. Remember, each single bond is 2 electrons. So he is not happy. And if the central atom is not happy, nobody's happy. You've all heard the saying, if mama ain't happy, nobody's happy, right? Okay? So we got to get nitrogen to have 8 electrons. So let's go back and see what the instructions say to do. If not, convert 1 or 2 of the lone pairs of the terminal atoms into a double or a triple bond. So here's where we might need to add a double or triple bond. We're going to steal one of these pairs of electrons. Let's see if I can find one. There we go. This would be a good one. And we're going to put it over here. These little sad face. We're going to change it into a bond. Okay? Now we're going to double check. Make sure nitrogen's happy. Make sure all the oxygens still have 8 electrons and see if everybody's done. So I can sort of draw a circle around nitrogen. See, is there 8 electrons here? 2, 4, 6, 8. Yes. Remember, each bond is 2 electrons. I can draw a circle around each of the oxygens. Make sure each oxygen has 8 electrons. 2, 4, 6, 8. That looks good. 2, 4, 6, 8. That looks good. 2, 4, 6, 8. That looks good. Looks like I'm done. The problem with this one, and here's where I'm teaching you something that's a little different, is why does this oxygen here get to have the double bond? Why isn't it this one, and why isn't it this one? In other words, why can't I draw this like this? And now this one would have 6 electrons, this one would have 6 electrons, and this one would have only 4 electrons. And if that's true, then why doesn't this oxygen, well I did, why doesn't the bottom oxygen have the ability to have the double bond? So let's draw that one as well. Okay, 1, 2, 3, 4, 1, 2, 4, 5, 6, 1, 2, 4, 5, 6. If I check all 3 of these pictures, they all work. Say, aren't they the same thing? No, really they're not. Okay. And when you have more than one different structure that all fulfill the same requirements, these are called resonance structures. Resonance structures, according to your textbook, I'll give you the official definition. Resonance is a condition that occurs when more than one valid Lewis structure can be written for a molecule or ion. So this is valid, this is valid, this is valid. So Mr. Debski, how do I write my answer? Okay? Do I have to draw all 3 of them? Yes, if you do, that works. Okay? But there's an easier way. Okay? So I'm all for easier ways. So the way we would draw a resonance structure is we would put a single bond to each of my oxygens, like we had before, and we would use a dotted line to represent the fact that what's really going on is that these electrons are here some of the time, here some of the time, and here some of the time. They spend 33 1/3% of the time in each of these locations. So really what they're doing is they're floaters. Okay? They're kind of like, they're community property, if you want to think of that. They are literally shared between the whole molecule. And since we don't want to draw 3 pictures, if we can draw one, we're going to draw it as a dotted line to represent that sometimes there's a double bond here, sometimes there's a double bond here, and sometimes there's a double bond here. If we do that, each one of these oxygens is only going to have 4 electrons around it. And again, I'm just drawing some of them like this and some of them like this. We'll see why on Monday. So if I draw my picture, draw my circle around each one of these, 2, 4, 6, 8, count that as a bond. It works. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, well, too many there. But we know that it's only a partial bond. So it spends 1/3 of the time here, 1/3 of the time here, 1/3 of the time here. To make this a complete answer, we have to do the same thing we did Friday, or today's Friday, yesterday, and show that it is still a -1 ion. So this is nitrate, NO3, with a -1 ion. So this is called a resonance structure. When you see a dotted line like this, it's showing you that there's a partial bond there some of the time. We can share it here, here, and here. Okay, questions? So we've got molecules. We've got like pH3, we've got double bonds and triple bonds we can form. We've got polyatomic ions we can draw, and lastly we've got resonance structures. Now you might want to jot this down. The textbook says, and this is on page 258 if anybody wants to jot a note where it's coming from, the location of the lone pairs and bonding pairs differs in resonance structures. The molecule ozone, O3, and the polyatomic ions nitrate, nitrite, sulfite, and carbonate commonly form resonance structures. So you'll just see these on some of these polyatomic ions: carbonate, sulfate, I think I said sulfite, and so on. So there's some very common ones that you might run into in as you start to draw some of these. Okay? Good. Let's do this next. Pass these out. Okay, did I collect news articles? Yes?
Yes.
Just set it on the floor behind you. Just sit in the back and get extra pieces of paper, just set it on the floor behind you. Let's work one or two of these with you, okay? And you can let period one know that I didn't have time to do this with them, so if they want to watch the video, it might help them with their homework. Which one of these do you think looks tricky? So your homework is going to be the whole front side, okay? Who wants to pick one of these to torture us with for the next 5 minutes here?
Is this the front?
No, the front is A through H. Okay, the back is 1 through 10. We're going to save the back side for next week for review when we start studying for the chapter and for a few maybe miscellaneous bellwork questions. So don't lose this piece of paper. Bring it with you. Can you write on this paper? Absolutely. Do you want to write on this paper? Maybe not, because there's not a lot of room here to draw these. It's up to you how big you draw. Okay? So which one do you want to do, Kenny?
H.
Let's try it. I haven't done this one myself, so let's figure it out. Okay? ONCL. That looks bizarre, okay? We got one oxygen, one nitrogen, and one chlorine. I would not ask you to try and name this. Don't panic, okay? Because I don't know how to name it. Mono, oxy, mono, nitro, chloride? I don't know. Oxy, mono, chloro, mono, I don't know. I don't know what it is. We've only done things with 2 elements, so we can look it up. But we're not going to. So, which one of these goes in the middle? So here's where that rule comes into play. First one, who goes in the middle? Now I got 3 elements, so obviously one of them has to be in the middle. Maybe the 2 are going to go on the 2 sides. Is it oxygen, nitrogen, or chlorine? Raise your hand. Kenny,
Nitrogen.
how do you know?
Because it's the closest to the left.
Closest to the left. Okay, good idea. So we're going to put nitrogen down, and we're going to stop for a second. We're going to add up all our valence electrons. See, take a minute, add them up. Let's see if we all get the same number. I'm not going to do it for you. We're going to add up 1 O, 1 N, and 1 C. See how many you get. We were in the last period, by the way, and Reed Brannon came in. He's the teacher's aide for the science department. He was in his Kemper's class this morning, and she had a cool way of remembering the 7 diatomic elements, which you need to know. Remember that? And those 7 diatomic elements, he said, they start here with nitrogen, and if you remember nitrogen is number 7, then 6 of the 7 form us number 7 right here, which is kind of cool. 1, 2, 3, 4, 5, 6. So nitrogen, oxygen, fluorine, chlorine, bromine, and iodine form a number 7. And then the 7th one is actually hydrogen. There's no way, easy way to remember that. But 7, NOF, Cl, Br, and I, and hydrogen are your 7 diatomic elements. How many electrons you got? Who's raised your hand? Hey, I need more hands than that. Can everybody figure this out first? hands, good. Everybody should have a number written down. You're gonna take this, plus this, plus this. Cole, what you got?
18.
Yes.
Yes,
Everybody got 18?
sir.
Okay.
Yes,
So how do we get that? We got 7 for the chlorine, we got 5 for the nitrogen, and 6 for the oxygen, okay? And we should get 18. Now, next step, what's the next step we need to do? Okay,
Do you divide by 2? You divide by
yes, divide this by 2. Always divide by 2. Because a pair of electrons is what makes a bond, not 3 electrons. Divide by 2.
Nah.
Where's my math whiz? Where's my math whiz here?
Oh, nah.
Drew?
9. She's at 11.
We need to find 9 bonds here, okay? So we're going to start. Next step says start by putting what? What is the next step? Somebody tell me in your own words. And if you need to look in your notes, you can. Bella?
Start with a single bond.
Start with a single bond and attach the other atoms to the central one. So if nitrogen's in the middle, I'll slap the chlorine on this side and the oxygen on that. You can put them on the top and the bottom. You can put them on side and side. What you can't do is this. And some of you, if you're not careful, you're going to do this. Oh, just slap them all together. Well, you just decided nitrogen was the middle atom, so don't do that, okay? So nitrogen has to be in the middle. So spin that puppy around and put it on this side here. Okay. So I have 2 bonds out of my 9 used. So we're going to start loading up the outside atoms with electrons. 3 more pairs. 3 more pairs. So I got 3, 6, 7, 8. Got 1 more pair of electrons left over. Now if you go back and read the steps, it says if you have extra electrons, what do I do with them? Raise your hand, please. Ooh. Kenneth?
You put them on top of the center out.
Central atom. Okay. Now, we need to take a step back. We need to look at our results and say, is everybody happy?
No.
No. Why not, Victoria?
Because nitrogen doesn't have a full.
Nitrogen's only got 6 electrons. Even though oxygen's got 8 and chlorine's got 8, nitrogen's only got 2, 4, 6. So then it says, if not, what do I need to do, Tempe?
You like the double bonds?
Steal a pair of electrons from one of these 2 and turn it into a double bond. So literally, I will try one or the other. I'll figure out if it makes any difference here. So let's try those 2 right there, since it lets me pack these 2 electrons, turn them into a bond, and make a double bond. Now let's look at each of the atoms individually. Does this guy have 8? 2, 4, 6, 8. Yes. Does nitrogen have 8? 2, 4, 6, 8. Yes. Does chlorine have 8? 2, 4, 6, 8. Yes. Now, the question is, can we do the same thing with chlorine? Is this going to lead to one of those resonance things we just did? Good example. Glad you chose this one. So, let's find out. Let's do exactly the same thing we just did, but instead of stealing the electrons from here, let's steal the electrons from the oxygen and see if we get the same result. So I'm going to steal these last 2. Hey. Not going to let me do that. So this time I'm going to steal these 2 electrons and put them with the nitrogen. No. I had 2 electrons with the nitrogen. All right, steal these 2 electrons and make the double bond here. Okay, so we're following the same steps, repeat the same process, but instead of putting the double bond here, using those 2 electrons, I'm putting the double bond here using these 2 electrons. Let's see if I have 8 electrons. Yes?
Z.
Yes?
Yes.
Yes?
C.
Okay, good. So we have a potential here for a resonance structure. It's 50% likely the electrons will be here, 50% likely the electrons will be here, and we would draw the final answer on this one, just like we did for the previous one, with a dotted line on both sides, the oxygen and the chlorine here. And in this case, you say, where do I put those extra electrons? We only had 2 pairs of electrons here and 2 pairs of electrons here. So I think if we do this right, okay, we had 9 pairs. 1, 2, 3, 4, 5, 6, 7, 8. Oh, and I forgot those guys. Don't forget 9. So there are still 9 pairs of electrons in my final answer. 1, 2, 3, 4, 5, 6, 7, 8, 9. pairs, 9 bonds. And really what the dotted line is showing me, that there's a pair of electrons bouncing back and forth between the two atoms. Good? Russell?
So you gotta make sure that the central atom has 8 valence electrons.
Every atom has to have 8 electrons when you're done, with the exception of hydrogen, which can only have 2.
Like nitrogen has 5, and I was kind of confused. Like, why did you put 2 dots on top of nitrogen for?
Because when we go back, let's follow the steps through, okay? I had 9 pairs of electrons. We found a home, the step before this. We started with single bonds. 1, 2, 3, 4, 5, 6, 7, 8. I had 8 pairs of electrons, but I have 9 available. And the steps that we covered in class yesterday says if there's extra electrons, the central atom gets them. I can't put them out here, because that would give him 10. He can't have 10. I can't put them out here. He would have 10. That can't happen. So the central atom gets them, if possible, if he's not already got 8. Okay? And then, since nitrogen still doesn't have 8, now we need to start looking at double bonds and triple bonds. Does that answer your question? Just work through those 7 steps from yesterday's notes. For the first couple times you do it, have those 7 steps. They're in the textbook if you need them. They're in your notes. Okay? And we're going to call it quits for today.
Thank you.